Yeah, I'm on here.
Welcome. Welcome to Vaayusastra's Future Scientist Meet, chapter number 17. Today is something a special day because today is not only a presentation day, but also it's going to be a company presentation. Not a normal company, it's a company which is formed by bunch of school students. The people who is going to change humanity, as I say all the time. Yes. Now they formed a company, they have a CEO, CTO, they have a MD, they have a research scientist, and they register their company as well in msme. How cool is that? And today, even though we have four or five companies under Vaayusastra Aerospace Young Researchers School, and this is the first team presentation. We are doing this for past 1 year. And first time we are going to do the first team live presentation. And the company name is Aerospace now, and they're officially registered MSME startup now. And the CEO Rakshan and the MD Sanjay, and we have a CTO Riyansh, and we have a research scientist Naman. So all going to do some research they have done. And more than that, okay, that's one part. More than that, what I am interested in is, I want to know what this company is going to do and what's their future dream, what is their vision. All these things, I'm so excited because this is like one of the dream of Vaayusastra to create this spark among this young generation. Yes, I am emotional and I'm excited as well. Okay, let's give the stage. The stage is all yours. The Aerospace Now team. Rakshan, who wants to take it? Yes.
Of course, yes, Jagu. Of course. So, give me a few minutes. I'll share my screen.
Yes.
Until then, you can go on introducing it.
Till then, Sanjay will start with an introduction to our company, our future aim, and how will this company go forward.
Yeah. So we'll begin. So, is my screen visible?
Yes.
So, hey, my name is Sanjay, and today I'm going to talk about the futuristic plans of aerospace. Aerospace now has a wide vision. We are aiming to help humanity to go to the next level by sending rockets and rovers to do research on many planets, so that humanity can build civilizations in other planets. In the next 10 to 15 years, we are going to start doing a project and sending the rockets to space. How are we gonna bring humanity to the next level? As I told before, we are gonna build civilizations in other planets, so that if Earth gets destroyed, humanity can survive. Do you all know Elon Musk? Yes, he is the CEO of SpaceX. He's aiming to settle on Mars. Same idea?
Sanjay, the slides are not changing. Do you guys put any slides?
We are even aiming to send satellites to planets that exceed Milky Way galaxy. So that space travel on the universe is like a road trip now. We are also aiming to send multiple rockets and satellites into unknown galaxies to find new life. Thank you. Now, let me introduce my team members and they'll talk about their futuristic plans. First, I would like to call Rakshan to the stage. Rakshan?
Yeah. So, hello everyone. Welcome to Vaayusastra. My name is Rakshan Kumar. I'm the CEO of Aerospace Now. Today, we're going to present on the topic exoplanets. Before moving on to the topic, I would like to introduce this wonderful crew of folks. I'm the CEO. Sanjay is the MD. Riyansh is the CTO. Naman is an employee or the chief scientist. This is our logo. Special thanks to Vaayusastra Aerospace and Mr. Jagdish Khanna for supporting us so much to develop such a wonderful company. Let's dive deeper into the topic. What are exoplanets? Before moving on to the topic, I know a lot of them presented on the topic of exoplanets, but this will be a bit different. There will be a few exoplanets, but there won't be much about them, but much about their discovery and a lot more information. So I hope you like this. Let's check it out. What is exoplanet? Exoplanet is an extrasolar planet that's outside our solar system. In the 1980s, Earth and the other planets orbiting the Sun were the only known planets in the universe. Since then, astronomers have found thousands of planets circling other stars. These planets are called as extrasolar planets or exoplanets for short. Astronomers have discovered more than 3,500 exoplanets by 2018. Some scientists found signs that there might be even 3 or even more planets outside our solar system. Many of these first exoplanets scientists discovered were huge gas giants. However, more research is still needed to confirm that these planets exist. There are 4 different types of planets: gas giants, Neptunian, super Earth, and terrestrial. Some examples of exoplanets are Kepler 452b, Kepler 16b, Pollux b, etc. Naman, can you please go on mute? The types of exoplanets. We talked about this in the previous slides, but I'm going to give you a brief overview. Terrestrial. Earth-sized or smaller, mostly made out of rock and metal. Some could possess oceans and atmosphere, and perhaps other signs of habitability. Neptune-like. Similar in size to Neptune and Uranus, with hydrogen or helium-dominated atmospheres. Many Neptunes, not found in our solar system, and are just smaller than Neptune, but they are larger than Earth. Gas giants. The size of Saturn or Jupiter, much larger. They include hot Jupiters, scorching planets in close orbits around their stars. Typically terrestrial or rocky and more massive than Earth, but they are lighter than Neptunian. They might have or might not have atmosphere. It depends. First exoplanets, now less. Kepler 186, ASA, Australian Space Agency, Kepler Space Telescope. Astronomers have discovered the first Earth-sized planet orbiting the star in a habitable zone. The range of distance from the star where liquid water can cool on the surface of an orbiting planet. The discovery of Kepler 186f confirms that planets that size the Earth exist in the habitable zone of the stars other than Earth. While planets have previously what? Guys, please. Okay. Yep. While planets have previously been found in the habitable zone, they are at least 40% larger in size than the Earth. And understanding make up Kepler 186f is challenging. It's more reminiscent of Earth. This is an image, an artistic image of Kepler 186. Osiris Rex. The planet HD 209458b, or the Osiris, which I'm familiar. It's already an exoplanet with an astounding list of firsts. The first exoplanet discovered transiting its sun first with an atmosphere. It's actually the first with an atmosphere is Kepler-22, but it was discovered. But Osiris was discovered with an atmosphere, but it was not proved. The one first which was proved with an atmosphere was Kepler-22. First observed to have an evaporating hydrogen in 2003 by same team of science. And the first to have an atmosphere containing oxygen and carbon. Furthermore, the blow-off effect observed by the team during the October and November 2003 observations with the Hubble had never been seen before. Scientists have been detecting oxygen and carbon in the atmosphere. Sorry, it's better. Scientists have detected. The first time these elements have been observed in a planet behind the solar system. The oxygen and carbon found in the atmosphere are evaporating at such immense rate, or the existing of new class of extrasolar. The Clothian balance, or the dead pole of completely evaporated gas giants, has been produced. Kepler 16b is not going to be presented by me, and I'm going to give it Sanjay. Jago, I think you have to unmute him.
Sanjay. Okay, unmute Sanjay.
Yes, sir. Kepler 16b. The existence of the double sunset as portrayed in the film Star Wars more than 30 years ago is now a scientific fact. NASA's Kepler mission has made the first unambiguous detection of a binary planet. Planet orbiting two stars 200 light years from Earth. Unlike Star Wars, the planet is cold, gaseous, and not thought to harbor life. But its discovery demonstrates the diversity of planets in our galaxy. Previous research has hinted at the existence of binary planets, but clear confirmation provided exclusive. Kepler detected such a planet known as Kepler 16 by observing transits where the brightness of a parent star dims from the planet crossing in front of it. Next slide, please. Pics of Kepler 16. Discoveries. Astronomers found the first two exoplanets in 1992. These exoplanets look nothing like Earth. They orbit a dead star. When a star dies, its center sometimes collapses into a dense glowing city. This type of leftover star is very different from the sun. Scientists were surprised to find planets orbiting these remnants. 3 years later, scientists found an exoplanet moving around a star like the sun. But this exoplanet is quite different from it. The exoplanet travels around its star in only 4 days. Our planet Earth travels around the sun about 365.25 days, and when it is a leap year, it travels around the sun about 366 days. But this planet just travels around its star only in 4 days. That means its orbits very close to its star. Because it is so close to its star, the exoplanet is much hotter than Earth. In addition, the exoplanet weighs as much as Jupiter. That means it is more than 300 times as massive as LTAB, the hottest exoplanet discovered so far, is even warmer than some stars. Next slide. Continuation of discoveries. This type of large hot planet is known as hot Jupiter. During the next decade, astronomers found many other large hot exoplanets. Some are so close to their stars and their surfaces are hot enough to melt iron. Earth, ever since, as it orbits the telescope, takes pictures of planets, stars, and other objects in space. Because the telescope is above Earth's atmosphere, the pictures are much clearer than pictures taken from Earth's surface. Scientists study the pictures to learn about outer space. Sometimes they find exoplanets in the pictures. The exoplanets look like faint glowing objects around the stars.
Thank you, Sanjay. Thank you. So moving on. Yeah. Next, Naman, can you take over?
Sir, I would like to. So far, Earth is the only planet scientists know of that has life. But discoveries of the 2010s came closer to finding planets that are like Earth. A few of these planets are the same size as Earth. They have signs of an atmosphere. They may even have water. Water was critical for the development of life on Earth. Scientists now know of more than 50 exoplanets that may be able to support life. Now, the support. The Hubble Space Telescope orbits 353 miles, or 569 kilometers above Earth's surface. In the mid-2000s, scientists began finding large exoplanets that are farther from their stars. Some of these planets were much farther from their stars than Pluto is from the Sun. These exoplanets were found using the Hubble Space Telescope. The Hubble Space Telescope was launched into space in 1990. It has been orbiting Earth ever since. As it orbits, the telescope takes pictures of planets, stars, and other objects in space. Because the telescope is above Earth's atmosphere, the pictures are much clearer than pictures taken from Earth's surface. Scientists study the pictures to learn about outer space. Sometimes they find exoplanets. In the picture, the exoplanets look like very faint glowing objects around the star. Now, let's talk about the shifting starlight. To find most exoplanets, scientists look at changes in starlight. A planet does not create its own light. Instead, it reflects light from the star it orbits. Scientists can sometimes look for changes in starlight to find exoplanets. Because of gravity, a planet and its star pull on each other. Gravity's effect on two objects depends on each object's mass. For example, the Sun is more than 300,000 times more massive than Earth. The exoplanet GJ 436b is approximately the same size as Neptune. I'm pretty sure I said in my own presentations about 18 or 16 times the mass of Earth. The Sun's pull on Earth causes Earth to orbit. Earth also pulls on the Sun, but Earth is tiny compared to the Sun. Its pull does not have much of an effect. The Sun does not move nearly as much as Earth does. So let's do the continuation of shifting starlight. Most exoplanets are much less massive than the stars they orbit. For this reason, an exoplanet's pull is so small that astronomers will not see the star move. But the exoplanet's pull makes the starlight appear a slightly different color. Scientists can detect this change even from far away. The change tells scientists that an exoplanet is pulling at a star. So, scientists can study these changes in starlight to determine an exoplanet's mass. Exoplanets that are more massive cause larger changes. Less massive cause smaller. So when the first exoplanets were discovered, at most exoplanets take a few hours to cross in front of a star. Scientists used this method. It helped them determine that the planets were as massive as Jupiter. Jupiter is 318 times as massive as Earth. Strength of gravity also depends on the distance between a planet and its star. An exoplanet that is near its star pulls on the star much more than a similar sized exoplanet that is farther away. Its pull causes a greater change to the starlight. By studying the starlight, scientists can estimate how far an exoplanet is from its star. By the mid-2000s, scientists had found a few hundred exoplanets, but most were too massive to be much like Earth. Plus, compared with the stars they orbit, most exoplanets give off very little light, so it is rare for exoplanets to be spotted directly. Astronomers needed a different method to find Earth-like exoplanets. Two major consequences or the drawbacks from this is that the distance, there's much dimmer light falling on them, and some of them depends on the mass as well, because the more the mass, it's expected to have even more gravity. So, the Kepler telescope, the key to which made this entirely possible. This large telescope was launched into space in 2009. It orbits the Sun and looks out at stars across the galaxy. Scientists use the Kepler Space Telescope to find smaller exoplanets. As an exoplanet passes between its star and the telescope, the exoplanet blocks a small amount of the star's light. The Kepler Space Telescope detects these tiny dips in starlight. When scientists notice regular dips in a star's light, they know an exoplanet is present.
Moving on.
Okay, so from top to bottom, the Kepler Space Telescope is 15.3 feet or 4.7 meters long. To calculate how far that exoplanet is from the star, they measure how often the dips happen. Each dip means that exoplanet has complete one orbit. A planet that is farther away will take longer to move around the star. For this reason, exoplanets with bigger orbits have less frequent dips in light. So, if the dips are much more frequent, it shows that the exoplanet is closer to the star, and vice versa. When it's far away, less frequent the dips.
Okay. Thank you so much, Naman. It was a very good explanation. Moving on to Riyansh, the CTO. The stage is all yours, buddy.
So thank you, Rakshan. So now let's see how these astronomers calculate the radius, calculate the circumference, calculate the area. How do they get to this solution? So the thing over here is the astronomers can also estimate the exoplanet size. To do this, they measure how long the planet takes to cross in front of or transit its star. And they study how much light the exoplanet blocks when it passes between a star and a telescope. The larger the exoplanet, the more light it will cover, because it will create that big space or that big dark spot on the star's light. Like how during a solar eclipse and a lunar eclipse, if the Earth blocks the sun, then the shadow formed is large. While if the moon blocks the sun, the shadow form is small. The same way over here as well. So an exoplanet will bore, and even you can measure the distance. So if Earth is closer to, suppose if we shift the orbit of Earth ahead of Venus, so then it will block more light because it is very near to the sun. But if it is compared to the position right now, it will block less light. So these two criteria are also used to measure the distance. Next slide, please. So one more method to do this is a transit method. This is a exact method how to do this. So the transit method also makes it possible to study the atmosphere of the transiting planet. When the planet transits the star, light from the star passes through the upper atmosphere of the planet. By studying the high resolution stellar spectrum carefully, one can detect elements present in the planet's atmosphere. Because like nitrogen, if there is nitrogen present, it will emit a different color of light. There's oxygen present, it will emit a different color of light. So what will happen is you can get to know whatever gases, what elements, what are present in the atmosphere. So then you can, if there is oxygen present, you can understand that if this is suitable to, like, if it is suitable to live or not. And then, if the planets may give themselves away when they pass in front of a star and dim some of its light. The passage of a planet between a star and its Earth is called transit. So, like I told you in the lunar eclipse, an example in the previous slide, what we did, the main term for this is transit. I use transit in the usual slide as well, the previous slide. There are many transit. This is why we are explaining the exact transit method over here. So, if such a dimming of light is detected at regular intervals and lasts a fixed repeated length of time, then it is very likely that another dimmer object is orbiting the star. Some of these transiting objects might be small, dim stars, in which the pair is called eclipsing binary, but most of them are planets. Some continuation of transit method. Astronomers can glean some very important information about planets detected using this method. As a planetary transit, it is periodically in nature astronomers can determine the planet's orbital period. An additional bonus to that of the transit method is that you can hint the planet's atmospheric makeup if it has one. So you can notice what, like I told you, you can the different gases will emit different colors of light. This will be very, so this will help us look at a atmosphere if it has, because many of the planets don't have an atmosphere. So you can also learn about an exoplanet's atmosphere during the transit. As it transits, some light will go through its atmosphere, and that light can be analyzed to determine what different atmospheric elements influence its particular dispersion. So I don't did not explain this because I've already explained this and told you about this. So now let's look after how many we have come across. So total exoplanets are 4,521. Confirmed planets discovered by Kepler telescope are 2,402. Kepler project candidates, like the planets discovered by Kepler, which are yet to be confirmed, are 2,361. This 4,521 does not include the yet to be confirmed ones at all. It only includes the confirmed ones. So confirmed planet discovered by K2, the telescope named K2, is 467, while the confirmed ones are 889. Confirmed planet discovered by TESS, one other telescope, is 155. One of some TESS product candidates integrated into Archive, like they are not being taken into consideration that specifically, are 4,511. And current day TESS project candidates at Exofop are 4,511 only, and yet to be confirmed TESS project candidates are 3,051. Now let's conclude this presentation by a did you know fact. Kepler 22b was the first planet outside Earth known to have an atmosphere. So this is a very big fun fact. Like this is the very first planet to have an atmosphere. Now I would like to hand it over to my CEO, the CEO of our company, Rakshan Sai, to conclude this presentation by a quote and regards.
So much, everyone. So the scientists of today think deeply instead of clearly. One must be sane to think clearly, but one can think deeply and be quiet and sane. This was a quote by Sir Nikola Tesla. and I hope this is the end. Thank you so much. Regards, the Aerospace Now team. What if there are extraterrestrials in one of those exoplanets that we looked out? You never know.
Audience, if you have any
All
you want to
for
interact
another
with-
presentation. Thank you so much, everyone. Thank you so much. I'd love to see your regards. I'd love to hear your views. Anything. You can unmute. I think Avinash has his hand raised. Probably I have to unmute him. And every one who contributed in this presentation, every single viewer, thank you so much.
Well, you're welcome.
Okay, this is the first team presentation, which is going live. And
Avinash, do you have a doubt
yeah.
or do you want to give a feedback?
If anyone have any doubt, please.
So I don't have a doubt. I'm gonna share my feedback, but I request
Please,
not
please.
to, share this. I don't want my feedback. I want it to be shared personally.
Yeah, sure. Send
Yeah,
it me in
Avinash,
chat.
for
I
that-
don't want it to be streamed on YouTube. That's the reason.
Avinash, for that, I have a Google form. You can put all your feedback if you want it to be personal.
No, I
something.
just wanted to highlight with you guys. That's the reason.
Yeah, tell me.
Some feedback I have to highlight.
Okay, Riyansh, you can share the Google Form link in the chat box. I'll put it in YouTube.
No,
Hey,
sure.
send also the word wall link.
First, I'll share the quiz, then I'll share the.
One is Rakshan. Your science and voice modulating. Again, your voice, you're modulating your voice in such a way that I can't even understand what you're saying.
Yeah.
So one, you have to improve on that. Try to talk in normal Indian English. I'm talking in Indian English. I'm not talking in American English. It may feel like that, but I'm not.
That comes to me automatically.
Okay,
Because
Avinash.
you're always talking. Yeah. No, I'm
Okay.
not done, Riyansh. I'll do that. Then second thing, I have a question. I have a few questions.
Please go ahead.
What is reminiscent?
Can you repeat it?
Reminiscent.
Reminiscent. Okay. So reminiscent is nothing but okay.
So reminiscent is a thing which allows you to recall something or remember about something which has happened in the past, basically. So
Amazing presentation, Aerospace Now team.
Thank you so
I think
much.
Avinash had one more doubt. He mentioned 2 doubts.
See, not done. I have quite a lot.
Very
Riyansh,
good.
I think the meaning you have given me now, that is for reminiscence, not reminiscent.
Reminiscence is the ability. Reminiscent means, see, it's a term. That's it. It's a term. Reminiscence means it's moving on.
Okay.
The ability to do it. And reminiscent is nothing but it's what it is.
Okay.
Yeah. It's what
Next,
it is.
yeah, what is this law of effect?
Pardon? Can you be the question? Can you?
What is this law of effect?
Probably can you put in the chat?
Oh, fine. Law of effect. Law of effect. And then, what is the CHTHIONIAN planets?
So should I answer both of them?
Yeah, please.
Okay.
That'd be great.
Blow off effect. See, it's a kind of like a effect that how can I say it? See, wait a minute. How do you, it's related to finding an exoplanet or discovering exoplanet. How the way you find an exoplanet is the planet sends out some radiations, okay, which I know that it's hard for sound and other radiations to travel in space, but Earth, we too send some kind of radiation, and that's into outer space, which may be or may not be visible or which can be heard by any other living organism anywhere in the universe. So this is the basic law of effect.
Okay, then what is the planets?
Can you repeat?
What's the Thonian planets?
Did anyone get
Avinash, I
it?
think there's just some
Type it.
Yeah,
the
type it.
disturbance that Avinash is saying.
Yeah.
Just a minute. I'm gonna repeat
So
it.
after the question,
Thornian
I'm
planets.
going to have a
What is the
separate.
Thornian planets? What's the Thornian planets?
Plutonium planets.
It's not Thornian actually. It's Thornian. It's just Thornian planets. Side.
It's a cluster. It's a planet cluster.
Oh, fine. Next, where are you getting all these data? Are you mentioning the source? Because you're presenting a live presentation. So you
Actually,
also
this
have,
is see. This is my own content. I didn't see. Wait a minute. No. The source is. I took it from. This is kind of like bits and pieces. I took it from everywhere. So and I understood and retyped it in my own words. That's the basic.
One main source of this information is Wikipedia, but Rakshan has not absolutely copy
Yeah,
pasted.
actually, I didn't even take even a single word from Wikipedia.
No. Rakshan. Everything is included in Wikipedia, but it is not entirely copy paste or
so
something.
some
you can
parts
check it
are
out.
copy paste. Some parts are copy paste.
It's like
Yeah,
a research
actually, no.
study.
So some parts and have to be, if you want to describe some stuff, some parts.
No, see, actually, I didn't copy paste anything. Tell me.
Yeah, this is a research study. Avinash, this is not.
I
like
didn't copy paste anything. Can you mention at least one which I copy pasted from Wikipedia?
Okay, now my question is, you showed a tabular column. I'm sure you copy pasted it.
That has to be.
That has to be done. That
Copy
has to
pasted.
be.
Okay, where did
See,
you
that's-
get it from? Where did you get it from?
Naman gave it to me. Ask him.
No, that is Sanjay. That is Sanjay.
Okay. Avinash, this question and answer is like, this is a research study project. Obviously, the data might be
No,
from a lot of researchers.
why I asked is because, see, if they are copy pasting or taking from all these, they should also mention it because they are doing a live.
They'll put reference links. I'll make them put.
I didn't copy paste it. Literally.
No, this table now. This table, I'm sure you have copy pasted it. So if you put a reference, it would mean that they are the authors, you're just using it. Even though it's without their permission, you have to put a copyright at least.
Yes, they'll put the reference links. They will
Raghu,
put the
to
reference
understand, to get about, if Avinash still wants to get to know about this website from where we got it, you can please
Now I'm done.
unmute.
I'm done with all my questions.
You
Otherwise,
can unmute Sanjay. Sanjay has an entire view of
No
it.
issues, no issues. I can understand the thing. Just we'll add reference link. We will add reference link in that.
So,
Don't worry. So anyone has any other question? Just you can put it in the question.
and I am actually
Just
sending.
raise your hands. We can discuss. Now I want to have a separate interview kind of session for aerospace now. So because like the presentation is a research study. It's not like a theory creation or like something creating new. It's like the exoplanets. The studies have been already done. Kepler collected a lot of data. So this aerospace now team studied a lot of papers, lot of websites, refer a lot of websites. They made one presentation and they are doing it. So don't have to be like too much. So this is a research study. So this for information purpose, and for those who are interested about in exoplanet, this will be useful. Instead of going to a lot of papers, they can go through this video and they'll understand a lot of things. Okay. Okay, nice. So anyone has any other questions can put it in.
Please reach out.
Raise your hands. We can. Pranav, you have any questions for team or any feedbacks related to session? So how do you feel about this?
I like the presentation very much actually,
Nice, nice.
and I got like fully my mind was in exoplanets. Now I did the quiz and actually I got everything right.
Awesome.
Nice.
So it's like you understood it. Good job. Good job, buddy.
Bhairavi, what do you think about team presentation today? Do you have any feedbacks for them?
The presentation was awesome. I attended the quiz and I also got all the questions correct.
Nice.
I understood the whole topic. It was like very easy.
Nice. So if you have any suggestions, you can put it in the Google form link. Any positive comments you can give it.
Yeah, okay, sir.
Srijit, you have any questions for aerospace now team?
Oh, sure.
Okay, now let's have a small interview session with this team.
Yes, sir.
So this is a young team which is like newly formed. So what is the vision behind this company, Aerospace Now? Yes, who wants to answer? Like,
Can I go on?
okay, Rakshan, yeah.
Yeah. See, it's simple. Everyone, so if there's something difficult to understand, that if someone doesn't understand something which is very easy, okay, they use these two words, rocket science. Actually, until before I entered Vaayusastra, I thought rocket science was something very, very difficult. Okay. But after that, rocket science is one of my favorite and one of the easiest subjects for me, literally compared to it. So, and a lot of people think that space is so dense. It includes a person, okay? I'm literally. So, I wanted to bring this. Our vision is to bring space, which is thought to be one of the astronomy, which is thought to be one of the most difficult and one of the most challenging subjects, into something that can be understood by a layman. So in simple terms,
Nice.
make astronomy and space study easy. That's our basic vision.
So taking knowledge to every single one, like how Elon Musk's Starlink want to take internet to every single part.
Artificial intelligence.
Nice. So what's your dream, Rakshan? Like, what do you like as a person, not as a company, as a person?
Okay. My dream. I actually still want to be an engineer in any one of these space companies. NASA, maybe NASA, SpaceX, ISRO, ASA, ESA, Roscosmos, everything is fine. So I wanted to play a role. I want to play a role.
You will do. You will. Nice. Then let's introduce your team. Let's know a little bit more about them.
Sure. This is a wonderful group consisting of Riyansh, Sanjay, Naman. So what the role we played, what we did was, this is separation of work. So one of us. So before that, I wanted to give an introduction to him. The thing about Sanjay, he's the one who collected information, some of the information. He made a major role in making the presentation, and he's he's an awesome part for us.
Yeah, how did you form? How did you form?
What is it?
How did you get this team? Because I think I see all of you are from different schools, and one or two are like different grades. How do you get to form this team?
It's simple, solo presentation. So if Mr. X done a solo presentation and Mr. Y liked it, so he's coming in for a collab with Mr. X. So we did when Mr. X and Mr. Y did a presentation, and if it went successful, Mr. Z. So people start rolling in. That's simple.
Yeah. Okay, let's have some questions for our MD, CTO, and research scientist. Okay, let's go with Riyansh. Hi, Riyansh. So, CTO of Aerospace Now. So, what do you think Aerospace Now will be doing after 10 years?
Yeah, so our basic goal to achieve in 10 years is absolute drone technology. So what we want to do is, as everybody knows, in the future drones will be used for delivery, packaging, for a lot of stuff. So what our main goal is, we create drones from scratch, produce them and give it them to space agencies so that they can use to make stuff instead of rovers which take a lot of speed, a lot of battery and use a lot of supplies. So these drones will be small, battery consuming a lot of, it will reduce a lot of stuff. So what we here want to do is we will produce and give away drones and space related stuff to companies, to space agencies, and which will give us boost in our company as well and help other stuff to other people, the other space agencies to rise as well.
Something like SpaceX, like
Funding.
they build this Dragon space capsule, which sends people to ISS on behalf of NASA.
Yeah, so something like that only, but we'll not only do for one space agency like ISRO.
Okay.
We will do it for different space agencies.
International, for all the space agencies.
Yeah.
Nice. So Riyansh, personally, what's your dream? What do you want to become in future?
My personal dream was a computer engineer, and this field is very good for a computer engineer because programming stuff, how to design stuff, everything comes into those computer engineering stuff. So which is why I think aerospace is a good field for me, as I want to become a computer engineer.
Nice. I'll come back to you again. First, I'll finish them. Our MD, Managing Director Sanjay.
Yes, sir.
So, what do you think? Aerospace now? What's your role and what you'll be doing after 10 years with the aerospace now?
So, Aerospace now is just a startup company. We have just started about 2 months ago. Actually, we didn't even have an idea that we can start a company in Vaayusastra. So first I thought, okay, why not we just start a company? So I called Rakshan. Actually, he called me. He asked me, I would like to join your company. So I said, okay, I think you're the first person. Instead of me, you're the first person to join. He said, okay. We did presentations on X-ray telescope and gamma ray telescope. And we are slowly growing up with our members. We just started with 2 and we now 4 members. So I hope new members would join our team and we would grow. In the next 10 years, we would like to bring humanity to the next level. For example, humanity is still on Earth. They have not settled on other exoplanets and other planets that are in the solar system itself, like Mars, etc. They are going to implement Elon Musk's idea. He is aiming to go to Mars, but they're aiming to do it in many other planets. So next 10 years, we hope we will achieve.
Nice. Okay, well done. Okay, nice. Okay, now Naman, the research scientist, he already does one series, the solar system and exoplanets. Yes,
Yeah,
Naman. So, what's your dream and what do you want to, like, how you expect aerospace now to be after 10 years?
So first, let me answer the question on what will I do with aerospace now in the next 10 years. Probably as soon as we start to get revenue, maybe as soon as we get popularity, and we may actually get revenue, we might start to do things that really can impact space world. So let's say we can just like create something tiny but has a lot of capabilities, something like a drone or maybe like a robot, a tiny robot, but have the capability to do things that weren't really possible in the past, which might be considerably now if you consider the next 10 years to be the present. Unexpectedly, first of all, I was just doing my solos. And then all of a sudden, while I was like sitting on my bed, like Sanjay ended up calling me. Like first time I was an aeroscientist. I was an aeroscientist. and he just called me for no apparent reason. And just like Rakshan told, he wanted to collab with Aerospace. And then I was up for it, even though I was not the CEO or founder. I was up for it. And soon enough, I joined Aerospace now, and they had done the presentation. And from that point on, I just got the creativity to create the series and even more like things related to space. First of all, when I had joined Vaayusastra, I wasn't a big fan of space. But as soon as I joined after the 8 years course, research just came into my mind. I enjoyed space. From trying to become a mathematician or scientist, now I want to be an astronomer. So I know it might sound confusing, but till now I still say for, let's say in my main interviews, I would honestly just say that I want to become a mathematician. But externally, I would say that I want to become an astronomer. Why you ask me? Because, well, let's say I don't want to like jumble things up. Math, science, they they may be correlating, but it honestly doesn't make much of a difference. I want to be an astronomer. I want to be a mathematician. It doesn't really matter. But my ambition, where I want to be, I'm gonna strive for it. So hopefully it goes well.
Nice, nice. So I've been following you all of your presentations. I think for almost more than like 8 to 9 months or around a year. Most of your presentations lies outer space, asteroid mining, solar system, exoplanets. So how do you think you guys you can answer like a team? How you as aerospace, how you guys want to take humanity to next level? Like I want some
As I told,
vision, like
we want to colonize exoplanet so that if Earth's going to be destroyed, we can and humanity's race will survive.
okay.
Creating things that are unexpected to happen in the past. Let's say we know perpetual motion machines. They are they are said to be not possible right now. Imagine we created one. Created something that will supply the entire world with energy. Something that can benefit humanity a trillion times more than what is now. That would make a huge difference. Okay, Rakshan is yours.
Okay. So, according to me, knowledge is power. According to mostly everyone. So, making people aware of this extraordinary universe and extraordinary substances, things in our universe. What's more than what's better than sharing the biggest factor? So first, we let everyone know that. I think everyone would have seen my Mars colonization, Neptune colonization, and exoplanets colonization PPT. So I would have stated this word in all three of them. Our Earth is at risk, and so it is. So we probably have destroyed our Earth, and this thing is on Earth. So we probably have to change everything.
We also have a problem overpopulation.
Overpopulation, yeah. Earth is in vital danger. So saving Earth, it's actually a big deal.
Yeah, it's a huge task.
Yeah, it's moving millions to a completely new place.
No,
And we're just oh come on, we can't. Okay. So we can't shift the entire population of Earth. But we'll try our best. We're still in the 0th level.
zero. No
We will.
danger.
We will.
We are taking steps, and I hope we will achieve it.
Riyansh, you want to add something?
No, but my actually what experience I was just want to share my how did I come across with this company is the I just this is my first presentation with this company.
Oh, actually, second.
No, but live presentation and also second presentation. But the first presentation which was there, I did not contribute much to that. It was already prepared by my other members. So what I think I actually was earlier in another company, but then because of some issues I had to leave that company. But and that day only, fortunately, they had the presentation, Rakshan, Parvesh and Sanjay. Parvesh is an ex team member of our team. So what happened is they had, and I got inspired that they had taken a very good topic, they explained in a very good way. So then that day I contacted them. That was the day I joined the company. So and this company I think is had given me like was a great good experience to learn as all of the people have a different perspective, so we get to know different ideas and how different stuff out of it. So this company was a good startup.
So,
Anything else from the viewers? Questions? Reviews?
yeah, you have any questions? And anyone want to join aerospace now? You can.
We have a fifth
Please,
member. We have a fifth
Rakshan,
member.
just send them the official.
Yeah,
aerospace
mail
number.
ID. Mail ID. Yeah.
Mail ID and number also. And we have a fifth crew member who is awaiting to be added in the crew,
Okay.
who is Ranadeep Reddy. So
Nice.
we'll be adding him by today.
Nice.
Yeah, by today, officially by today.
He'll be added officially.
Brilliant, brilliant. I just love to see.
From next week, he will officially present his next presentation.
Beautiful, beautiful. This is a very nice to see. There's, it's not like this team is like not like formed in one day. They took time. They had a lot of trial and errors. They have miscommunication. They have this is what needed right now. So even though the people viewers who are watching maybe thinking these are kids, what they are going to do. If you look at the past, if you look at the history, if you read the history, the people who had vision when they were young, they actually changed the world. Starting from Wright brothers, Elon Musk, Abdul Kalam, all these people had vision when they were young. Or even take Ramanuja, Tesla, Newton. So like just read about everyone when they were at this age, when we trigger the spark, this spark can ignite a lot of minds, or it can even take ignite to the next level. So that's what we are trying to do. I'm glad that I'm happy this team is on the right track, and I'll be always with you guys, don't worry. So we will take this to next level.
Thank you, sir.
And audience, if you want to share any of your thoughts, you are welcome. So raise your hands, I'll unmute you so you can talk anything. What do you feel about this company? How you guys like this teams and all these things? So if you want anything to share, just raise your hands and unmute. And there are few more companies also will be presenting on upcoming weeks. Okay.
There are many companies, sir. Like
Amazing presentation. Aerospace Now team.
Thank you.
It's amazing.
So Satyaki, what do you think about this team formation, company building by young students?
Yeah. I feel very happy.
Okay.
Thanks.
By the way, you want to say something?
I think aerospace now will take humanity to next level.
Nice.
Okay, that's great. Yeah.
Okay. Well done. So this is the first team presentation. Well done. Thank you so much. I'll post this whole interview as a separate video so that this becomes one intro book for aerospace now. And the presentation will be on a separate video as well.
Thank you.
Okay.
Yeah.
Done, done. So well done. Let's give a huge round of applause. Unmute yourself. Let's thank you.
I'm gonna
Aerospace
clap
now.
myself just to thank the
Good job, everyone. Good job, team.
Superb, everyone. Superb.
So I know that the first is always a tough one. If you take anything, the first is always tough. So they came forward first. So I am very glad. So if you even if you take for vaccination, you'll be scared. Like that. The first person says he got vaccination, he say I'm fine. Then people follow. So the first is always, I believe, they create biggest impacts. Okay,
They'll
see
most
you all
likely be
in
the
the next
carrier.
presentation on coming Saturday. Until then, from bye bye from Jagu and Vaayusastra.
Bye bye.
Bye
Jagu,
bye.
stop the
Goodbye,
live stream.
everyone.
Jagu.
Bye,
Stop the
everyone.
live stream, Jagu.